The adoption of cloud-native architecture came with a specific promise: faster software delivery. Yet, for many enterprises scaling their engineering teams, the flexibility of the cloud has introduced layers of operational friction that frequently delay production updates. Over the last 10 years, DevOps established a new operational baseline. Organizations adopted automation, infrastructure became programmable code, and continuous delivery became standard practice. But as those same organizations scaled, their technology stacks expanded. The shift into multi-cloud architectures, the implementation of Kubernetes, and the integration of GitOps pipelines caused a massive explosion of necessary operational tooling. On the left side of this diagram, we see a massive wall of complexity. Forcing software engineers into part-time infrastructure operators dramatically increases developer cognitive load. Constantly configuring dense networking, security, and infrastructure severely drops their capacity to process software architecture. The immediate consequence is a reduction in hours spent writing value-generating business logic. Teams face intense burnout maintaining environments. Meanwhile, operational risk climbs as manual configurations drift. There is a structural gap between DevOps culture and execution. Defining how teams work together doesn't automatically provide the tools to scale those practices safely. Closing that scale gap requires a systemic shift. Instead of individual product teams solving operational problems from scratch, organizations must move towards centralized, reusable platform engineering capabilities. Platform engineering provides a practical layer for DevOps by abstracting common operational complexities into reusable, productized capabilities that developers can consume directly. The primary vehicle used to deliver these capabilities to the engineering team is the Internal Developer Platform, or IDP. Looking at this architecture, the Internal Developer Platform acts as a centralized hub, aggregating fragmented tools into a unified interface. Expanding out, it links directly into continuous integration, automated infrastructure provisioning, container orchestration, and observability platforms. It is critical to distinguish this platform from legacy IT ticketing systems. An IDP does not require a developer to submit a request for a server and wait days for a manual review. The functional mechanism here is API-driven self-service. Engineers provision the computing resources they need, on demand, without human intervention blocking the deployment pipeline. By centralizing the complex underlying tooling rather than the organizational approval process, internal developer platforms restore developer autonomy. Giving engineering teams total architectural freedom forces individual product developers to make dozens of redundant, low-level infrastructure decisions for every single application they build. Platform teams resolve this decision fatigue through a structural concept known as the golden path. As mapped on the right side of this model, the golden path provides pre-approved automated templates. Notice the icons on that route. These templates weave together distinct systems, connecting Git repositories, triggering CI/CD runners, and configuring Kubernetes into one workflow. The operational strategy is straightforward. Make the architecturally correct way to deploy an application the easiest way for the developer to ship it. Developers are not strictly locked into these templates. They are permitted to build custom solutions for specific edge cases. But if they choose to leave the paved road, they assume the maintenance burden of that bespoke architecture. For everyone else, golden paths accelerate new hire onboarding and daily deployment frequencies. Engineers write code and push to production instead of reinventing operational workflows from scratch. Decentralized DevOps carries a specific enterprise risk. When 30 different engineering groups build their own isolated deployment pipelines, the organization ends up with 30 different interpretations of corporate security policy. Historically, teams treated compliance and governance as an auditing layer, a manual external review process applied right before production release. Platform teams move controls directly into the developer workflow. As shown by the shield and gate here, security guardrails are embedded into the golden path templates. Standard procedures like vulnerability scanning and network restrictions become automated events built directly into the platform. This architecture shifts the compliance burden away from the application developer and places it into the infrastructure code managed by the platform team. Any application deployed via the golden path automatically inherits the organization's required baseline security posture by default. Embedded guardrails provide the mechanism enterprises need to accelerate their delivery timelines without proportionately increasing their regulatory risk. Engineering leadership must quantitatively prove that an internal developer platform actually reduces cognitive load. Building the infrastructure is useless if it does not translate to efficiency. We measure this success through specific proxy metrics for engineering velocity, decreased onboarding time for new hires, higher daily deployment frequencies, and a reduced mean time to recovery during incidents. Yet many enterprise implementations fail to move these metrics. The primary failure mode is treating the platform as a mandatory top-down IT initiative. When organizations implement rigid mandates, the operational pipeline ends up grinding to a halt, jammed by the very systems designed to optimize it. Forcing platform adoption through strict compliance creates shadow IT. Engineers will bypass any system that slows down their ability to ship code. The corrective approach is to treat the platform as a product. This mindset requires platform engineers to view internal software developers as their primary customers. They must actively seek feedback, identify bottlenecks, and iterate on the interface to improve the user experience continuously. Lasting platform adoption is organic. It is driven entirely by the platform's ability to seamlessly remove friction from the developer's daily workflow. Platform engineering evolves DevOps into a sustainable enterprise operating model. Scaling cloud architecture relies on curating systems that abstract complexity, rather than simply purchasing and stacking more standalone operational tools. Technology organizations achieve efficiency by prioritizing developer focus. This principle is highlighted in the bottom banner of this model: reduce developer cognitive load to increase engineering velocity. An organization's ability to innovate is strictly gated by its ability to protect its engineers from the overwhelming operational realities of the cloud. To implement this effectively, technology leaders must follow 3 essential steps when architecting their internal platforms. First, treat the platform strictly as a product. You must prioritize developer experience and friction reduction above all other metrics. Second, start thin and scale later. Do not attempt to build a massive, all-encompassing platform on day one. Identify the single highest friction workflow, such as cluster provisioning, and solve that specific bottleneck first. Third, pave the golden path rather than building walls. Drive adoption organically by ensuring the most compliant architectural decision is also the path of least resistance. The most successful platform teams build systems that engineers actively want to use, turning infrastructure from an operational bottleneck into a competitive advantage.